Alrighty then, so welcome back to another slash devlog slash tutorial. And this is gonna be like probably a simple one. We're gonna cover three topics over this. One is a bug fix from the previous video on the gameplay ability system. And the other two ones, I thought it was something, simple to find on the web, but apparently it isn't. So those are pretty common among, low poly and, stylish games, those kind of things. And which is basically the health bar of any enemy on the top of the head, and that hit effects, which basically, just change the material of the enemy, uh, for a blink of for a couple of seconds to red, and then just turns black to whatever the material was. So giving a demonstration of, whoops, let me just open the map that doesn't have actually the any of the sound effects. So there we go. So first of all, we have our character. So our character is going to be on my game is specifically it's going to be the character like base sort of thing. Where I'm going to program everything basically inside of it. So you're going to program all classes like archer or warrior, mage, and everything of the sort. So we can branch out of this character and we can reuse that code for enemies and AI and that kind of stuff. So we have the character. So basically the blueprint or the C++ class is pretty much the same as you can see. But when I'm controlling the character, I don't have my health bar on the top of my head because that's kind of useless for me. Uh, I'm gonna have some different sort of UI to cover that, but that's pretty much what enemies usually have. So if I'm controlling the character, I'm not gonna have this health bar, and regardless of the angle of the camera, you can see that basically it's gonna follow the screen. And the same goes for the hit effects, which is basically whenever I hit the character, you can see that it blinks as a red for a couple time, like deadline, a delay of 0.2 seconds basically, and it blinks as red and also has some sort of hit points on the top of it, as you can see. So you know, similar to what an action RPG looks like usually. Um, and this is pretty much what we're going to cover in this video. So stick around and let's get started. So first of all, I'm going to show how I fix my initial bug. If you watch my previous video on the gameplay ability system, basically you saw that I have some default parameters over here where I set my strength, I set my max stamina, my initial health, my initial magic points, my initial speed or whatever. And I set this basically so I can create later on enemies and other classes, and I can mix around between that as much as I want. Or the level designer could just tweak whenever he found that maybe a character or an enemy is too much OP, or it is just it's not uh, providing enough challenges to the player. So basically, he can just change that. And yeah, so I was changing that to 20 or whatever the number was, and it was not actually changing. And that was actually pretty easy to fix. So the issue was I was setting everything on my constructor of the gas attribute. So I had my, initial attributes or whatever inside of it. And that was pretty, uh, okay to, get it like initial default values. But when I was setting this attribute to my character, whenever I was creating that attribute, let me just find this over here somewhere. The ability component. Where is the attribute? Let me just find attribute. Attribute. Oops. There we go. So I have my attributes over here. So whenever I was creating that attribute, basically, I was not setting the default values over here, and which actually isn't possible to set in the constructor based on how the gameplay ability system is actually built on. So I would need to either have a data table or something like that, or maybe a default effect to handle that sort of initial parameter. But I didn't want that. I wanted to be on the character specifically on the level, not the level on the editor. So we're right at where it is today. So I would like to fix that. So I figured that if I set this attribute, the default attributes over here would crash but it was crashing because I hadn't initialized the ability system, which I do on the begin play to be uh, specific. Let me just find the begin play really quickly. Begin play, there we go. So I start my gameplay ability component, which basically, set it up to use the attributes and everything of the sort. And then I can just, set it up the default attributes the way that I want it to. So basically I just grab it, whatever I set inside of the attributes, which is basically what I set over here, and then just make sure that I set it again to the current value. So I grab my max health, my max stamina, my max speed, and just set it up on the begin play basically. If you were looking for a multiplayer solution, probably would need to have like some sort of hazard authority or something like that, some specific checks for game for multiplayer, which is not my point here. So it's just to fix that issue, and that was pretty much what I did. So that already fixes. So if I set, for example, 25 over here, and if I set 1,000 over here, for example, as a speed, you can see that he's gonna move around a lot faster than he was before, and he's gonna punch a lot faster as well. And as you can see, the damage is now 25 based on the strength. And the same goes if I set to 50 and I set the speed to 2,000. There's a limit on, not based on the speed, but there's a limit on how fast he can punch it. Otherwise, it's just not going to trigger any notify. You can see that he's a lot faster. He's like, a lot faster. And I can punch it as well. And there we go. 2 punches is now dead. So, I can change whenever I want it here. And that was the initial idea. So that was fixed. So moving on now to the actual health bar, which is basically a simple widget, but it's a widget made on C++ sort of it. So we have the user widget class in C++. We can use that. We can bind some attributes, force that user widget to have some sort of attribute. So if it doesn't have visually, it's just not going to compile basically. So let me show you how I did basically. So I went back to the C++ class. I create this UI folder over here, generic because it's a generic UI, and I create this simple health bar. Basically, what that is, if we go to new C++ class and you look for user widget, whoops, there we go. Oops, there we go. That's class. So I just created one of that and name it simple health bar. And on my simple health bar, I didn't set anything on the actual, I didn't create any constructor or anything of the sort. I just let it, as it is. But on my public, I created this progress bar, which is basically a U progress bar class, which is basically this, item over here. So this is a U progress bar, and I put this meta over here, which is bind widget. So if I don't have a progress bar with that specific name, which is health bar, so you can see that if I set that to health bar 2, for example, and try to compile, it's going to fail. And you can see that it's requiring a binding to a health bar. So it does have a progress bar, but doesn't have the exact name, so it doesn't match the exact name of the variable over here. So if it doesn't match, it's just not going to compile. So this way, I can force the level designer to have some sort of elements that I wanted to, so I can later on manipulate this health bar into C++ later on. This is a way that I use. It doesn't mean that it's the best way. Some people use late instead, but I like this, visual, uh, that some sort of visual UI to actually, organize better than organizing in the code. So I just did that, and with that, I just on the let me just go back to whatever that is. So you can see that I have this under the UI folder. Now I create as well a folder here, character life, and I have this basically health bar. And this health bar is basically created based on that C++ class. So instead of widget blueprint, oops, that was not what I wanted to do. Let me see. Okay, that's just fine. So you could do that, like create a new widget blueprint, or you could just go back and create a new blueprint class and look for the simple health bar. And that should be pretty much the same actually. But the difference is whenever you create a new widget blueprint and you wanted to prototype or something of the sort later on, in order to force your C++ class to actually be able to, grab the elements or anything of the sort, you go to the class settings and you change the parent class instead of the user widget, you can change to simple health bar, and that should be about it. That was what I did, and it actually is complaining because it's missing the health bar component, which is, under the other one. So I just created this one to show you guys how I did it. Um, yeah, so that was pretty much it, what I did. I didn't create any, oops, I need to change the name over here again to health bar. There we go. So that was the start on how to do the health bar. Basically, I didn't create, if you weren't doing things as I am doing it right now, you could just bind, let's suppose it doesn't, you're not using the same class as I am using right now. You're not using game playability system. Um, but you're just using regular variables or whatever inside of the character to control, manipulate whatever the health is. You could just go back here and add a binding to it, and this binding could just grab it and do the math for you. Or you can create this binding as well in C++, but you could just create a binding to grab whatever the health is and calculate the percentage of it. So 1 is 100% health, and 0 is, dead, basically. 0.1 is 10%, and so on. So you could do that. I haven't done that actually because on the game playability system, when you're using that, it seems like even though you have different characters on the level, it would never update this because my character was with 100% health and he was using the same attribute somehow. I'm not sure why, but it seems that it's not, totally shared, I would say. So even though as you can see, it's updating, I had to manually change that health bar whenever I was updating this on the C++. So, but you could do that if you're not using game playability assistant. So you could just create a binding, which is not what I did because it wasn't working on my case. And basically on the C++ end, then what I did was whenever I was changing the attribute, let me just find whatever I was changing. There we go. I created as also like it's not, it's just a blueprint read only is not visible or edited anywhere as the other max health and max whatever it are. I just create this health before change attribute. It's a float one. And what I did basically is I just set it to 0. So, you know, as a default value. And before changing anything, which is this function over here, which is basically before changing any attribute, check if it is the health. And if it is, grab the health before actually changing. This way I can have the difference for later on to print it on the screen. What are the amount of damage that I'm giving it? So basically this, for example, would be 100. So it would store 100. And later on when it was changing, I could just calculate it and update the text on the screen with 10, like 100 minus 90, which would be the final result after this post execution. So it would be already, a 90 because after changing it, it's going to trigger this one. So if I give it, for example, 10 of damage, it would be 100 stored here, and then what it triggered that function, which is after changing from 100 to whatever that is, which is 100 minus 10, which would be 90. The value for get health would be already 90, so it would have 100 minus 90 printed at 10 on the screen as the combat text. But that's not the point. I'll get to that later on. But basically, what I did then, I just stored that health before, just so you can know where that came from later on. And after changing it, the health, what I did basically is before, doing anything, this is the combat UI. I'll do a quick demo later on. I call this function called update health bar, which basically passes me the current health and the max health. So I can calculate that to get this between, 0 and 1 in terms of percentages. And to calculate that is pretty simple. You can see that I have like a health UI basically, and I have this health bar widget inside of my character. So if I go back to the health, I created this UI widget component, my character. So if you can see that is the same for the combat tasks. And what that is basically, if you want to do that on blueprints instead, you can just find like widget, and that should be about it. This is the component I just set it on C++. So I created this widget component for health bar, and the same one, I created a different one for the combat text, basically. And whenever I was creating this one, I had to create this uh, as a sub-default object, usually. But there is a couple things that I had to implement it as well. I just set up the attachment to the same component, which is basically the root. And then this one is the tricky part because this widget, if you go back, let me just find this one, this health bar. This property over here called space. If you set that, the default one would be scroll world, which is basically it's not gonna face the camera all the time. So if I set, for example, this to world, I'm gonna set right here so you can see it. It's gonna have it like the widget's gonna present to you here, but if you play it, you can see that it's not, depending on the angle you look at, it's not gonna be always facing the camera, which is a problem for me. So basically what I did is I set it up on the C++ on the constructor already that the screen, which is basically always looking at the screen. Although this brings the problem is of where to position that, so you have to try it, in error and see what's the best position for your health bar. So basically did that. I set the relative location to this one, and the widget class, I set it up the default one for that C++ class, which is basically the health bar. Uh, why I did that though, it's not gonna, you're gonna need to manually later on change this to the actual blueprint you created. But I just did that because later on I can create unit tests for it. So, I can create unit tests and can cast to the class, update the health bar and, doing unit tests on it based on it. Okay, so basically after creating this on the gas attribute, I create this function as well on the, not on the gas attribute, sorry, on the player. And whenever I'm changing the health, I'm calling this update health bar and passing whatever the current value is and what is the max value of health. What that does is it first try to cast on the widget component, and it's trying to cast and get this health bar, which is basically the class of the health bar, and it's only going to work if your widget on the graph settings, it needs to be parent on the simple health bar, which is basically C++ class. Otherwise, that's how I set values on widgets through C++ code, basically. So I try to cast and grab the widget for the widget component that I set it, and if it is a simple health bar, then I just grab the actual health bar element, which is that U progress bar, and then I calculate the percentage to set it. So basically what I did, I clamped the value of the current value divided by the max value, and the minimum value needs to be 0 and the max 1. And that's going to give me, for example, if I divided 90 by 100, it's going to be 0.9. If I divided 80 by 100, it's going to be 0.8. And the same goes 15 divided by 100 is going to be, something. So this is going to give me the percentage put on that progress bar. And then I call these hit effects. But that's how I update the health bar, basically. So what that does is whenever I change the attribute health, I just call this function update health bar, which basically grabs from my component the actual health bar and set the percentage. Instead of doing that on the bind function, because that was not working for the gameplay ability component, the gameplay ability system. It was not changing because my health wasn't changed. The health of the player I'm controlling it wasn't changing, so it was considering as unique, even though it wasn't. So that might be a bug that I need to report to Epic, but so that way I change it. So the health bar is updated that way. But now, how do I, put the little guy to, red and then to, back to its original color? I create this function head effect. So whenever I'm changing the value, so I'm, since I'm already changing the value, so I'm just gonna apply this head effects. Probably there's a bug into this, and I might need to figure it out later on because I don't think I'm protecting this to whether this is positive or not. Maybe I need to add like a couple if here. So if get, oh, no, never mind. I'll do this check later. So yeah, I'm probably gonna need to do that. I do this check over here, so I'm probably gonna need to do that, something like this. Uh, So I'm probably gonna just copy it over here. Oops. So I can do that actually. Oops. So if I'm actually applying some damage, which is basically if my health before the change is actually bigger than my health, my actual health, which means that I'm not adding up data, I'm actually subtracting it. So then I can do that basically. So I can do everything here. I can, fix that up. So it's only gonna update the health bar if I'm decreasing the health. Okay, I see why I haven't done that because I may actually want to upgrade the health later on. So yeah, let me just leave it what as it was before. So never mind. Never mind this first 5 seconds, this last 15 seconds or so. So yeah, that's how I upgrade the health bar. That's why I haven't put inside of this F because I may want to put some sort of spell that the enemy could regain health later on. So I want to update that properly. Okay, so that's how I did this health bar. So I can close that up. And the same way, the health bar is just, if you look it up, let me just open up again the health bar. There's no, there's nothing special to it. It's just, it's like a health bar, as you can see. There's like this size of 125, and it's aligned to centered, and it's filling up from left to right, and there's this color. And there's nothing in it actually. There's nothing special to it. So it's pretty simple, pretty straightforward. So you know, okay. So let's go now to the hit effects, which is basically something that I figured that isn't something quite put on the internet so far. Even though it's a common effect that I see, uh, it apparently isn't something that everyone. It was quite hard to find that actually. I found that how to make this onto a Reddit forum. I mean, I didn't want to do it that way, but I figured that it would be a lot simpler just to do it that way. But you'll see why I'm saying that because I thought that maybe the engine has something specific to do that already, but it seems that it doesn't. So uh, I thought on that first, which is basically changing the material of every single material of the mesh to whatever material I set it, and then wait for a couple seconds and then change back. But that sounds like a workaround, like a really forced workaround. Though it doesn't seem that I found something native to do so. But so basically what I did, I just create this head effects material, which is basically you can set the color, the emissive color, and pretty simple stuff. And then I create an instance of it. So if later on I want to change the color or something like that, maybe some character may blink blue or blink whatever I don't want it, so it just set it up this way. Maybe some uh, might be if the enemy is harder to kill, they may blink in the different color. So, but yeah, that's pretty much what I did. And inside of my character, basically what I did, I create this function, and this function is triggered whenever I update the health bar, which I see now that can be problematic as well because if I'm gaining actually it doesn't need to be that problematic because if I'm gaining health, it's going to trigger this hit effects as well. But I could just manipulate the material to keep blinking some green color, for example, which means that he's gaining health. It doesn't need to be as problematic as I think it would be. But basically, what this is doing is setting the hit effects and this function for every single mesh of my character. And as you can see, I have a lot of meshes in it. So I have my main mesh, and if I open up my character, I have some sort of clothing system to it. So I have my head, my shoulder, my chest, and each one of is a mesh specifically. So I have to set this hit effect for every single mesh that I have on my character. If you have just a um, one mesh into a character, one of these should be enough, basically. Sorry. Uh, Basically what I do then, I set the set effects. I'm going to show you in a quick couple seconds how I do that. And I set a timer. And this timer is nothing but more than a F timer handle. So it's just some sort of delay. So if on Blueprint, you would do something like this, like delay. or triggerable delay or whatever you want it to. But in C++, that's how you do it. Uh, I set this object, and then later on I can call a function, and the function is on delay and returns material, mesh material. So basically, if I set a delay and I wanted to after delay do something, that's how I do it. So I call it a delay. The delay is going to be triggered on this C++ class. After the delay is finished, I call this function, and the delay is going to take 0.2 seconds, and it's not going to loop. So it's just going to do it once. So let's go step by step, basically. So first, how I set the material. Before that, in order to set the material, I need to understand what are the original materials that I have. So you can see that I have a lot of variables in my character. So I created like a bunch of variables. So since I have a bunch of meshes in my character, I create the mesh material, which is basically the main mesh original material, the same for the head, shoulder pad, chest, and anything of the sort. I would need though to once I do change the clothing to update those variables later. So as part of this process, so I need to remind me myself that uh, once I continue with the inventory, include its instance and stuff so like that. But just something to keep in mind. So uh, I populate those variables on the begin play if I'm not mistaken. So let me just find it up. This, I think it's on the begin play. There we go. Yep, it's on the begin play. So on the begin play, whenever the character spawn, I just get the materials and set that all the materials that are from the mesh. And I set all the materials because some meshes may have one or more materials associated with it. Because in order to optimize the mesh, some meshes need to be 4K and resolution and needs to have so much details that, for example, a character, it may need a material for the face, a material for the clothing, a material for the weapon or something like that. So that's why I do that. So I grab all the materials that I have on this specific mesh, the main mesh, the same for the head, the shoulder pad, and whatever. I do that for basically everything. So I saved the original materials, and I do that because whenever I call that function hit effect, there we go. So whenever I call this function hit effect, I'm going to call this function set hit effects. And this function, what it's going to do basically is it's going to try to find the hit material. So if I have a valid hit material, which is basically a U material interface that I created, and I can add it on the editor. So basically, if I go back to my character and I go to the class defaults and look for what's the name of hit material? So hit material, there we go. I can set my material instance over here, which is basically my, that material that I just showed you guys. And if I have this material set it on the editor, which means if my character has a valid material set to it, I'll do a for loop going through every single mesh component. So I basically go to the mesh component, I get all the materials, and I do a for loop between each one of the materials, setting this hit material instead, like changing the material to this hit material, which is basically like this red color, basically. So I change the material, all the materials for the specific mesh that I pass to that red material, basically. And once I do that, I just end it up, basically. So what it's going to do, it's going to do the same thing for each one of the meshes that I have on my character. And after 0.2 seconds, it's going to call this function, which is on delay and returns mesh materials, which is basically returning the materials to the original values. So once that function is called, it's going to call these other functions here. And since the delay doesn't have like outputs or anything of the sort, it needs to be a void function with no parameters in it, which is sad, but uh, I create this function on delay and return mesh materials to return the materials to the original values. And then what I do inside of it, it's basically I call this function return material to original value, and I pass the original materials and I pass the mesh that is going to receive that material, basically. And I do that for each one of the meshes that I have associated with my character. So I do that for my main mesh, I do that for the hair mesh, the shoulder pad, the chest, and everything. And what it's going to do basically here, it's the same thing as before, but doing backwards. So what it's going to do, it's calling this function set material. And what it's going to do is for each material that we have on that array, I'm going to grab my mesh component, which I pass on that function and set that material to each one of the slot materials that that mesh has. So that's going to do basically this. The end result is once I set that, and again, if I don't have this set, it's not going to crash because if just not gonna do anything. As you can see, it doesn't do anything, and it's not crashing because I check whether the material was valid or not before actually setting. So if that's not valid, it's just gonna log invalid material, and it probably logged somewhere around here. Let me just see if I can find the log. Invalid material. Oh, there we go. So you can see that there's invalid material logs over here. So which would give me help on debugging. So I can set back that to whatever there we go, mi. There we go. So if I set that and it's valid, what it's going to do is it's going to change all the materials of my character to that red and then wait 0.2 seconds and change back to the original one. So boom, there we go. Boom, there we go. And boom, there we go. And I need to do that for all of that because if I, for example, doesn't set back, let me suppose if I comment this one out, and let me suppose I can just comment back the chest material. So let me just stop that and compile back. As you can see, if I don't set back to the original material, basically the chest is gonna keep as red, which is horrible. So keep in mind that whenever you set that material to a color, change that to the original material. So that's why on the begin play I store the original materials so I know which materials belong to each part of the body of the character, basically. Yep, that's pretty much how I did this. Oops, that's pretty much how I did this effect, basically. So as you can see, boom, the chest is kept as red. Let me just open up the asset so I don't lose the track of what I'm talking about. So as you can see, if I don't change back the material, boom, the body I need to fix that bug later on, but the body keeps as red. And then, yep, that's a bug. So also I need to unit test that later. So probably I already created the unit test for it, but So yeah, that's how I did the heat effect, which is pretty simple, but I wish there were some built-in feature inside of the Unreal to do that automatically. Like, okay, just set a heat effect and that should be about it. I mean, it's a simple thing. Okay, so that's how I did the change the health bar. Oh, and yeah, the health bar is only showing to the enemy, as you can see, even though it's on my main character, it's only showing to the character that I'm not controlling. And I did that basically through the spawn function. Let me just found, it's not the spawn, the possess function. So I override the possess by function. And what I did basically is I call the super so I don't screw anything up. But if the controller class basically of that character is AI controller, and I do have a health bar valid, then I set the visibility to true. So I present the health bar. Although if the class is not a AI controller, which means it's me controlling the health the character, I just set the visibility to false and I propagate that to the children. So that's how I don't show the health bar for myself, but I show to the enemies. So yeah, there we go, health bar and heat effect done. Now how I did the combat text, and that's also one of that has a lot of tutorials out there, and so many of them are completely wrong. And I'd say completely wrong. For example, most of the tutorials you're gonna see out there are gonna have, are gonna spawn one widget per damage, basically. So if you hit 10, it's gonna create a widget with 10 and add it to the viewport. And it's gonna do the same for the next hit, the next hit, and the next hit. So at the end of it, you're gonna have so many widgets created in the memory that your game it's gonna run out of memory eventually because that's gonna be stored in the memory somehow. It's not going to be deallocated by the tutorials that I'm seeing at least. So the cleanest way to do that is, of course, you're going to need to add the widget to the viewport, but that is the same way as I did the health bar. So you create a widget component inside of your character. In my case, let me just find the health bar because it's right below it. Health bar. There we go. So I create a widget component called combat text. There we go. Combat text. I do the same as I did for the health bar. I set it up the attachment. I set it up the location. The widget class is also another simple combat text widget, which is basically a C++ class created in the same way as the health bar. Though this simple combat text widget has a text block called text damage text, which needs to be in there, and it has this UWidget animation called floating text animation, and this, of course, this function as well, which is playing that animation. I haven't found a good way to gather or bind UWidget animation, so it may not be, it may not be the best way to bind an animation to it, but at least it's the best way to present that on the screen. Uh, the cleanest way to avoid spamming your memory, basically. So basically, what I do is on the combat text, I do have basically a demo text, which is that needs to be in the same way as the image text, and I have an animation for that text basically. And let me just go back to the timeline, which goes. Let me just set that text to 100 so you can see it. So there we go. So that is the text. It was empty, so that's why I set it empty, because I don't want to present anything by default. I want to set that. Otherwise, if I set that way, you can see that it would spawn 100 at the top of every time for everyone. So which is pretty bad. So I leave it empty later, but you can set it whatever the size you want it to later on. It's a simply canvas panel. I set it up the size here to custom, and I set it up the width and the height. And you can set it up the way you want it to as well. But basically, what I did is, whenever at the beginning of this animation, and to create an animation is pretty simple. It's pretty simple. You can just add a new animation here and select one of those. So, or you can just create a new animation, call it an animation the way you want it, and do the same way as well here. So I just named that animation floating text basically. And what I did here basically was, on my text on the 0 position, I set the color and opacity to 1. So you can see that there is one here. I clicked on this add keyframe basically. I'm going to create a new one so I can show you guys how I did it. So I set my position back to whatever that is. And I clicked on the health over there. There we go. So I set it up, the color and opacity, the position to be 0, and that was pretty much it. So the same I did for the position of that. So I select my text on the position. On the Y position, I set that as well. So I created a keyframe on 0. And then I move it up 1 second. I think it was 1 second that I set it up. Yeah, it was 1 second. Okay. On the 1 second though, what I did is I just changed that position on the Y, and here you can do as much, as higher as you wanted to. I set it up to -50, but which is gonna create this effect, and I set it up the keyframe, which is gonna create this effect over here. So it's gonna move around the widget to the top basically. And later on the second number 2, I go back to the opacity, set that at 0, create a new keyframe, which is gonna do basically this. So that was what I did basically on this floating text animation. So as you can see, it's pretty much what I just said. So yep. As well, I set it up the keyframe as well here to be 1. So it would only fade out from 1 second onwards, but that's a preference choice. You can choose to fade out from the beginning to the end, so it's up to you. So that's pretty much what I did. So that's the animation. And on the construct event, I just set the floating text animation, which, as you can see, it's blueprint read write. So I can set that variable on the blueprint level. So whenever this widget is constructed, I set the floating text animation to my C++ variable. So I can, control it through C++. It doesn't mean that's the best way, it's just the way that I rather do it, which is controlling code logic through C++. And I create this function which is blueprint callable. It doesn't need to be called on the blueprint. I was prototyping, so that's why I created that way. Which is basically what if it has like a valid floating text animation, what's gonna do is gonna gather the damage to show, round it up to whatever it is, because it may have like a floating damage, like 10.5 or 10.5. You can round it up that way. And then I convert to that integer to text, in order to set the damage text element to whatever that damage it is. And then I play the animation, floating text animation, starting at the time 0, doesn't play more than once. Starts forward, plays from forward position, so 0 to whatever that is. The playback speed is 1, and it doesn't need to restart anything. So, yep, that's pretty much what I did. But where do I call all this logic behind it? And again, I created this comeback text, and as you can see, is this class settings is from that C++ class that I'm just presenting you guys. And I just created everything. It has the same damage text. It is a variable, so So basically, what I do is, when do I present this? In my player character, again on the comeback text that I created here, I set this as the default one for unit testing, for mocking and unit testing, basically. But on my character, as you can see, it has my WPP comeback text. So there we go. It is my blueprint with my text over here. Let me just delete that because it doesn't need to have anything. So instead of spamming your memory and adding that to the viewport every single time, which is gonna eventually crash your game running out of memory depending. Imagine if you're creating like some sort of multiplayer game that has countless amount of people. I don't know, 5 people from one team and 5 people from another team. Everyone is dealing damage on each other and into some minions or bots or anything of the sort. Imagine how much of UI would you spend to the memory and store it without even using it again after doing that. So just created one. It's simpler. Use the same one. So what I did is I set it up this one. I set it up the draw size. And again, this is testing. So it's the amount of size that is going to draw it. If you set it up too big, for example, if I set it up like 500 to 500, oops, it may not be at the center of the screen because it's going to create like a imaginary uh, transparent rectangle and put the text, as you can see, at the top of it because it's not centered, the widget. So it's trying error. Basically what I did is I grabbed the biggest number, which was 50, around 50 and 60, and I try and error 50 and 50, and that worked. So that's how I set it this to be at the center of it. So that's the draw size of these widgets, basically. And the position again is try and error as well, to put the back and the top into a position that you find useful. And where do I print that actually is whenever I take damage. So again, on the gas attribute, whenever I'm changing this health value, I can be upgrading or whatever. So whenever I take a damage, and how I do calculate that I actually take a damage. So like first I cast my widget. So I grab my player and I grab my comeback text widget component, and then I grab the widget and cast to my C++ widget, my C++ local widget. And if that's valid, and my health before change, which was, for example, 100, and I dealt 10 of damage, so my current health is 90. So if my health before change is bigger than my current health, it means that I'm decreasing my health. So then I play comeback text. So I grab my combat UI, call the function play comeback text, which is basically playing that animation. And so it's setting the text to whatever damage I'm dealing with there, and the damage I pass over here on the gas attributes as well. So I'm calling basically health before change minus my current health. It's the amount of damage. So my health before change was 100. My current health is 80. So my tax to present is going to be 20. And that's pretty simple. And if it's my health is 100 and my current health is 79 something, it's going to round up to whatever that number is. If it's 21 or 20 or whatever, it's closer to it. And it's going to call that function then with that value, and it's basically play that animation that I just present to you, which is basically this animation over here. And that's how we do it. Do, do, do. And of course, there was a bug as well, which was I was not setting the proper collisions after his dying. So, you know, whenever he was dying, he was pushing me back because of the collision of his back. So whenever my character dies as well, so let me just go back as well here. So if my character is dying, it is dying. Basically, I call this. I was calling already this set players alive to update my animation. But again, I'm detaching my controlling and setting a pending to destroy, which is basically it's gonna kill, destroy my actor in 5 seconds. And as well, on the setting player is alive, if I'm setting that to false, which means I'm killing the player, I'm disabling the collisions basically. So that's how I disable the collisions. So I stop my movement. I'm stop moving immediately. So it means that it's going to stop any animation that maybe be triggering at that point. And I'm also setting my collisions to no collision, ignoring collisions, and setting all the collisions properly to ignore it. So if I kill my player, let me just set like something bigger so he kills faster than let me just set to one punch. That should be enough. One punch, man. So one punch is gonna kill it. Boom, killed. There we go. 1, 2, 3, 4, 5, and it's gonna delete it. There we go. Our character is deleted. So I create this custom mock over here, and that's why you see some blueprint code, but it's just mocking. So I could test it out, applying damage to myself, so I could see whether this health bar was being updated properly if I had that. And also, I had this mock enemy spawn, which is basically just spawning another player. So if I kill my player, basically I can spawn a different one. And again, there is collision, so it's probably gonna push me back a little bit, but that's intentional. I can just spawn a player in a different position, so I can try again, kill it, try again, and I can keep going, keep going, keep going. So there you go. I think that was it that I had to present to you all. It's pretty simple stuff, but it's pretty useful, and I haven't found much of that, out of the internet so easily, I would say. And that's how you would do it as well. So please don't spam your memory by throwing a lot of widgets because that's going to eventually cause some trouble to you. Right. Thank you all for watching. Let's keep in touch. See ya.